Okay, so the plan for today is to finish 6-2, solving general applications of percent, cover 6-3, solving sales tax, commission, discount, and markup, and then start, but probably not finish, solving simple interest applications. Just a reminder, the Unit 2 exam is this week. It was available at 9 a.m. this past Monday, so a few days ago, and it's available through this coming Sunday, 11:59 p.m. As I've mentioned several times already, I strongly recommend uh, planning to complete the exam by tonight at the latest. Um, so again, that gives you kind of, one full weekday as a buffer in case anything goes wrong. That gives you a lot of options if any, changes need to be made or anything like that. I would not recommend waiting until Sunday, even Sunday afternoon or morning to complete the exam. There are just fewer options available if you wait until the last minute. Um, and as we've already talked about this, so I won't rehash this stuff, but the sample exam is posted. If you haven't completed the Examity practice exam, I'd recommend doing that as soon as reasonably possible. So ideally, even right after class today, going in, getting the Examity practice exam completed. That's been up for a few weeks, but if you haven't done that, make sure that all the tech is working right. At this point, it is getting very late to do the Examity practice exam, so you want to make sure that all the tech is working before you start the actual exam. All right. The quote of the day today is from Charlie Munger, one of the two legendary uh, heads of Berkshire Hathaway. He passed away about a year ago, but the quote of the day is better to add a sigma than to change a theory. And this is a quote from his lecture, Psychology of Human Misjudgment. You can find it on YouTube under that name. And it's about 24 minutes into it when he's talking about this. It's really an excellent discourse on not just finance and economics principles, but just kind of general human decision making and um, a bit of psychology as well. Um, so I think this requires a little bit of explanation. So he's talking about a statistics principle here, this idea of sigma or standard deviation or like something like volatility. And the context is that in finance, there's this idea called the efficient market hypothesis that roughly says that a person can't beat the market on average over a long period of time. That markets are efficient in the sense that one investment or another investment, the risk is appropriately priced into them. You might get lucky, but you can't get lucky over and over and over and over again, right? You can't win the Powerball 5 times in a row. You might win it once, or you might win a scratch off ticket, and hit it big one time, but you're not going to do that like every time you play. And uh, so this theory, the efficient market hypothesis, has won folks Nobel Prizes and so on, and seems to quite often be true in the market. But Berkshire Hathaway, was kind of one of the standout exceptions. They, year after year, would beat the market consistently on average over a long period of time, and the efficient market hypothesis essentially claims that's impossible to do. So every once in a while, somebody would bring up to one of the Nobel laureates from the efficient market hypothesis that, hey, well, how do you explain Berkshire Hathaway in light of your model? And at first he would say it's a 2 sigma event. And what that means is that, well, you're 2 standard deviations away from ordinary. That's not all that unreasonable. In other words, about 95% of the time, we would expect that this kind of performance wouldn't happen, say that Berkshire's recent performance. But it happens maybe 5% of the time, and there's a lot of companies out there. Sure, some of them are going to get lucky and beat the market over, a fairly short period of time. And then, Berkshire would beat the market for a couple more years, and they'd ask him, and he'd say, oh, it's a 3 sigma event, right? It's a 1 in 300 chance or so. There's well over 300 companies out there. We'd expect to see a couple of companies that would do this well for this long of a period of time. And then he got up to 4 sigma event, and he got all the way up to 6 sigmas, as Charlie says, which a 6 sigma event is kind of an absurdity. It's like, something that's almost never going to happen. And this is Charlie's statement: better to add a sigma than to change a theory just because the evidence comes in, uh, the way that you don't like. And I think, the deeper meaning to this is that each of us has a certain worldview about whatever topic it may be. When we get a new piece of evidence that conflicts with our worldview, what do we do with it? Do we just boot it out and say, oh, that's just a nonsense piece of evidence, and hold on to our theory? I mean, this Nobel laureate had obviously built his entire career around the efficient market hypothesis in part, so it's a little hard for him to say, ah, maybe my theory isn't as ironclad as I thought it was, or do we take that piece of evidence, seriously consider it, and accept that maybe our models don't work 100% of the time? So that's the quote of the day from Charlie Munger. And the video itself is worth a watch. You can find it under Psychology of Human Misjudgment on YouTube. It's just like an audio recording, and probably from 1990 or something like that, from judging from the quality of it. But yeah, you can listen to it like a podcast or something like that. So it's worth a listen, I think, if you're interested in either finance and economics or just really psychology and the way that people make decisions. Okay, so moving on to 6.2, finishing up general applications of percent. So we've got a couple more examples here, and then we have another subsection on percent change to discuss as well. There we go. So let's look at this next example. A grilled chicken salad at a popular fast food restaurant contains 650 milligrams of sodium, which is listed as 27% of the recommended daily amount. What is the recommended daily amount of sodium? So what do I have? I have, let's call the recommended daily amount X, and I have that 650 milligrams is 27% of X. Is, when we see the word is, we typically think equals. Does that make sense here? Yeah, 650 milligrams of sodium equals 27% of the recommended daily amount. So 650 equals 27% times X. We have a number times variable equals number. We divide both sides by 27%, or I'll choose to write that as 0.27. And I'll flip things around and I get X equals 650 over 0.27. Or I see that that's going to be, so 650.00, I would bump my decimal point 2 places to the right and do the same on my denominator. Or that's 65000 over 27. So let's come over here and do this division. Does 27 go into 6? No. Does it go into 65? Yes. 27 times 2 would give me 54. 27 by 3 is times 3 is going to be too much. 65 minus 54 is 11. Bring down a 0 and get 110. Does 27 go into 110? Yes, it does. 27 is a little bigger than 25, and I know 25 times 4 is 100. That should get me close. What's 27 times 4? Oops. Times 4. Well, that's 108. How did I figure that out? Well, I know that 27 is 25 plus 2. So 4 times 25 plus 2 is 4 times 25 plus 4 times 2. That gives me 100 plus 8. So we're going a little more quickly through some of the earlier arithmetic steps. But if you're not seeing these steps this quickly, or if you don't feel like making these kind of shortcuts using distributive property and so on, you can definitely go off to the side and write out the multiplication. But 4 times 27 is 108. 110 minus 108 gives me 2. Bring down a 0. Does 27 go into 20? Well, it goes in 0 times. And I suppose let's just follow the algorithm. 0 times 27 is 0. 20, and we bring down a 0. Does 27 go into 200? Yes, it does. Again, 27 is a little bigger than 25. I know that 25 times 8 is 200. So 27 times 8 would overshoot. Let me try 27 times 7. So 7 sevens are 49, 7 twos are 14, plus 4, 189. So that should work. 7 times 27, 189. 200 minus 189 is 11. So I end up with x is 2,407 and 11/27. On a scale of 2,000 milligrams, 2,000-ish milligrams of sodium, do we really care about a fractional amount of a milligram of sodium? Probably not. So we'd say x is about 2,407 milligrams of sodium. That would be our recommended daily amount, 2.4 grams of sodium. Probably a little high for an RDA for sodium. If you're eating a food where the sodium is measured in grams instead of milligrams, then that's definitely a high sodium food. Okay, next example. Emma gets paid $3,200 per month. She pays $960 a month for rent. A financial advisor recommends paying no more than 25% of your income toward your rent or mortgage. Is Emma below this limit? Or is Emma spending more than 25% of her monthly income towards rent? There are kind of two ways we could approach this problem. One, we could ask, how much of her income ought she be spending toward rent according to this principle? And then is 960 more or less than that? Or we can ask, she's paying 960, what percent of her income is she currently paying? And is that bigger than or less than 25%? Let's actually do it both ways. So method A, what's the maximum amount she should spend? So her income is 3,200 per month. 25% of her income is what she should spend per month, or the max she should spend per month. Let's say that that's X. We actually don't even have to do any equation solving here. So X equals 3,200 times 25%, but I know that that is 25 over 100, or that's 3,200. 25 over 100 is just 1/4, right? 3,200 divided by 4. Or that's $800. So what's the max she should be spending per month in rent or mortgage? Well, that's $800. She's currently paying $960 a month for rent. That's a little bit over what she would ideally be paying. Or B, we could ask what percent of her income is she actually currently paying and compare that to 25%. Oops. So she is currently paying $960 a month. And that's what percent of her pay. So that's, maybe we'll call it P percent times 3,200. We'll solve for P and express it as a percent. I have number times variable equals number. I divide by the coefficient of the variable, divide by 3,200. And I see that P equals 960 divided by 3,200. As a little aside, 960 is in units of dollars, as is 3,200. So 960 over 3,200, the dollar units cancel, and P is just a pure percent, doesn't have any units, as we would expect. Before I do any long division, I'm going to start simplifying this fraction a bit. I see that this is 96 over 320. Right? 960 is 96 times 10, 3,200, 320 times 10, and the 10s divide out. I probably see that I can find a factor of 4 in both the numerator and denominator. I could certainly find a 2, but the numerator is going to be 4 times 24. Right? 100 would be 4 times 25, and 96 is just 4 less than that. So 4 times 24. And 320, well, that's like 300s. So that would be 75 times 4. And then plus 20, which is like 5 times 4. So I think this would be 4 times 80. That does make sense because 8 times 4 is 32, times 10 is 320. So again, I'm taking some shortcuts in this arithmetic. Feel free to do that, or feel free to, you can divide out even just starting with a factor of 2, or if you recognize the factor of 4. 24 divided by 80. Well, hey, I think I actually recognize certainly another factor of 2, but probably even another factor of 4. 4 times 6 over 4 times 20. They can divide out. And I have another factor of 2 that can divide out, 3 over 10. Well, hey, that's just 0.3 or 30%, right? 0.3 is the same as 0.30. Bump the decimal point to the right and put a percent sign on it. I'm going a little quickly through this because we've already done these calculations, several times before. But just showing you that, you can do this, fairly efficiently if the numbers turn out nicely. If the numbers don't turn out so nicely, well, we just jump over and we do long division like we did up here, and we get either an exact answer or an approximate answer, depending on what we're looking for. So she's currently spending 30% of her monthly income on rent, and that is above the 25% benchmark. So, a little bit higher than what would be ideal. Any questions on either of these problems? Okay, so jumping down then to percent change, a couple definitions first. The increase, or the amount of increase, is the new amount minus the old amount. And the percent increase, I'll call PI, is the new amount minus the old amount divided by the old amount. So it's the increase divided by the basis, or the old amount. Okay, so an example, Ayodel got a raise in her hourly pay from $24.50 to $25.48. We would like to find the percent increase. So we find the percent increase by finding the amount of increase and dividing by the old amount, or the basis. So she got a raise from $24.50 to $25.48. So this is the new amount, and $24.50 is the old amount. So we first need to figure out what was the increase. That's new minus old, or that is 25.48 minus 24.50. I could do this subtraction, or I could realize that, well, 24.50 plus a whole dollar is 25.50. We almost made it there, but we were 2 cents short. So I can make that argument and come up with 98 cents. Or I could go through and, 8 minus 0 is 8, 4 minus 5 doesn't work, borrow 14 minus 5 is 9, and then 24 minus 24 is 0. Either way that I want to do it, I could say, if the increase was $1, then it would go up to 25.50. We didn't quite make it to 25.50. We were 2 cents short. 2 cents short of $1 is 98 cents. Or we could go through and do the subtraction algorithm and get the answer that way as well. So this is the amount of increase. Oops, crossed out half of my 98 cents. There we go. So this is the amount of increase. And then percent of increase, we have to divide that by the old amount. The old amount was $24.50. So I'm going to divide 0.98 by 24.50. If I bump this decimal point 1 to the right, I get 9.8 over 245. And let me come over here and do this. 9.8 divided by 245. What does that give me? Does 245 go into 9? No, it doesn't. There's my decimal point. Does it go into 98? No, it doesn't. Does 245 go into 980? Yes, it does. 245 is just under 250. 250 times 3 would be 750. 250 times 4 is 1,000. So it should go in like 3 times. 3 times 245. 3 times 5 is 15. 3 times 4 is 12, plus 1 is 13. 3 times 2 is 6, plus 1 is 7. So that gives me 735. So 980 minus 735. Well, 80 minus 35 gives me 45. And 900 minus 700 gives me 200. So I actually see 245 would go into 980. Not quite, not only 3 times, but I noticed that I got a whole other 245 out of there. It actually could have gone in 4 times. So let me just correct that. When we have bigger numbers like this, it can sometimes be a little bit hard to just get a gut feeling for how many times it goes in. So should have gone in 4 times. I guessed 3. I got a remainder that I saw was bigger than 245. And I just go back 1 step and correct that. Okay, it goes in 4 times. 245 times 4. 4 times 5 is 20. 4 times 4 is 16, plus 2 is 18. 4 times 2 is 8, plus 1 is 9. And I've checked that that makes 980. I have nothing left to bring down and a 0 remainder. So the percent increase is 0.04 or 4%. So this raise from $24.50 an hour to $25.48 an hour represents a 4% raise. That might not sound like a lot, but if you get a 3, 4, 5% raise, maybe twice a year over 5 or 10 years, it does really add up. Okay, next example. The price of a share of one stock fell from $8.75 to $8.54. Here we want to find the percent decrease. When we have an increase that is positive, we call it an increase. When we have an increase that's negative, we typically call that a decrease. So let's find the increase, which is the new minus the old price. It went from 875, that was the old number, to $8.54, that's the new number. So my increase, my amount of increase is going to be 8.54 minus 8.75. And I notice that this is a negative answer. I'm subtracting off more than I'm starting with. So I'll kind of flip it around and say the decrease is 875 minus 854. So the value of my stock decreased over this time because the new price is less than the old price. And I do my subtraction. 5 minus 4 is 1, 7 minus 5 is 2. Bring down my decimal point. I see my stock has decreased in value by 21 cents per share. So the amount of decrease is 0.21, and that would be in units of dollars. It's gone down $0.21 per share or 21 cents per share. And my percent decrease is the amount of decrease over the original amount, over the basis off of which I'm measuring it. Or that's 0.21 divided by 8.75. And what do I do here? Again, I bump my decimal place 2 to the right to make my denominator a whole number. Do the same with my numerator. Or move the decimal point the same number of places in my numerator, to be clear what I mean by when I say do the same. Move the same number of decimal places in the numerator as I did in the denominator, and I get 21 over 875. Does 875 go into 21? No, it does not. It goes in 0 times. Does it go into 210? No, it does not. Does it go into 2,100? Maybe 2 or 3 times. Let's check. 875 is a little under, or it's not a little, it's a decent bit under 1,000. So it should go in twice, but 800 times 3, I think 3 times 8 is 24, so that should give me something over 2,400. I don't think it should go in 3 times. 875 times 2, 2 times 5 is 10, 2 times 7 is 14, plus 1 is 15, and 2 times 8 is 16, plus 1 is 17. So 875 times 2 would give me 1,750. If I tried to squeeze another 875 in there, well, 1,750 to 2,000 would be 250, and then up to 2,100 would be 350. There's not enough room there to put another 875 in. So I'm pretty confident with just putting in 2 there. 2 times 875 is 1,750. And then 2,100 minus 1,750. So going from 2,100 down to 1,750 is like going from 2,100 to 2,000 to 1,750, or that's a drop of 100, then of another 250, or that is 350. Let's put in another 0. 875, how many times does that go into 3,500? Well, it's going to be more than 2. It's probably going to be more than 3, because 1,750 plus 875, if I think of like 1,700 plus 800, that's like 2,500. Seems like I could do better than that. Let's try 875 times 4. 4 times 5 is 20. 7 fours are 28 plus 2 is 30. 4 eights are 32 plus 3 is 35. And look at that, we go in exactly 4 times. 4 times 875 is 3,500. Nothing left to bring down. Remainder of 0. My percent decrease is 0.024, or that is 1, 2. Be really careful with the decimal point here. That is 2.4%. Oops. So my stock went down over this time period 2.4%. Or in other words, for each $100 I had invested in that stock, I lost $2.40. 2.4% of the investment. Any questions on any of this? Any questions on 6.3? Or sorry, 6.2. I'm jumping ahead in my mind. All right, on to 6.3 then. Solving sales tax, commission, and discount, as well as kind of like markup. I guess markup's kind of part of discount. Okay, let's start with sales tax. So some definitions. Sales tax is the tax rate, expressed as a percent usually, times the purchase price. And the total cost of an item is the purchase price plus the sales tax. I don't know why the plus sign is in there, kind of wonky. All right. I don't know why it did that, but so total cost is purchase price plus sales tax. So let's take an example here. The cost of a refrigerator was $1,242. The sales tax rate is 8% of the purchase price. And I guess, let me clarify, the purchase price was 1,242. The sales tax rate is 8%. Find the total cost. So the first thing we need to do is find out how much sales tax we have to pay, and then we have to add that on to the purchase price. So the sales tax is going to be the tax rate, 8%, multiplied by the purchase price, $1,242. We know the sales tax amount is going to be in dollars because this 1,242 has units of dollars. The 8% doesn't have any units, so we keep that units of dollars in our answer. %8 is 0.08, 0.08. So let's come over here and do this multiplication. 1,242 times 0.08. 8 times 2 is 16, right? The 6 carry the 1. 4 eighths are 32, plus 1 is 33. 2 eighths are 16, plus 3 is 19. 1 times 8 is 8, plus 1 is 9. So it gives me 9936 for my provisional answer. And then I put my decimal point in the right place. No decimal points, no decimal places in 1242, but 2 of them in 0.08. So we should have a total of 0 plus 2, or 2, in our denominator, or in our product. 99.36. So we paid $99.36 in sales tax. We also need to pay the full purchase price, 1,242. So the total cost is 1,242 plus 99.36. $1,242 is like $1,242.00, and 99.36. We make sure that the decimal points line up when we add or subtract. And then we just add down. So our total cost is $1,341.36. That's the purchase price plus the sales tax. Now, one little note, we might actually notice that there's maybe a slightly more efficient way to do this. Total cost is purchase price plus sales tax. But what is sales tax? It is tax rate times purchase price. But I can use my distributive property and see that that's just purchase price times 1 plus the tax rate. In other words, I could have come down here and said that my total cost is 1 plus my tax rate, 0.08, times the purchase price of 1242. Or that's just 1.08 times 1242. And if we did that, we do this first multiplication, the 8 times everything, and that gives me 9936. For the next place over, I put a buffer 0 in, but that's also a 0, so I can bump over one more place. And then I add down, I get 6, 3, 9 plus 2 is 11. Zero decimal places, 2 decimal places, should have 2 in my answer. 1341.36. I basically combined the multiplication and the addition steps kind of into one, instead of having a multiplication and an addition separately. So this might be something like strategically a bit simpler, but tactically a bit more complicated, right? This single multiplication problem is a little harder to do, a little more to keep track of, but I only have to do one problem, one computation. Here, the strategy is a little more complex. The kind of roadmap from the information to the answer is a little more convoluted. I have to do a couple of different problems, but each of the problems is simpler. Each of the steps is simpler. I think probably most of the time I would prefer this method. Probably most of the time I would rather do more simple calculations than fewer complex calculations. Complexity scales difficulty scales non-linearly with complexity. So if I have a calculation to do that, say, takes twice as many steps, it's probably a lot more than twice as difficult, or a lot more than twice as likely that I make an error, because the more steps there are to do, the difficulty kind of scales more quickly than the number of steps does. So I probably would still rather do it this way, like that. But it is worth noting that, this other perspective on this exists. Any questions on that one? All right, let's look at a different, a similar problem, but a slightly different bit of information. Orphea bought a coffee table for $400. The sales tax on the purchase was $38. Find the sales tax rate. And let me just be clear here. When we say she bought a coffee table for $400, let's say a total cost of $400. I copied these over from the book and didn't really think through the wording completely carefully. So in the context of the book, I think in the context of the problems in the book, I think it was a little more clear what was going on. So I want to just be really explicit about what exactly the information we have is, and what we're looking for. Okay, so she bought a oh, sorry, not total cost, purchase price. We'll do purchase price. We could have done total cost as well, but I think the numbers will turn out nicer with purchase price. Okay, so we want to find the sales tax rate. And if we come up here, this is what we want to find. We see that the sales tax rate relates the amount of sales tax paid to purchase price. So we have purchase price equals sales tax rate sorry, I'm having like a brain fart moment at the moment. It threw me off trying to figure out whether this was total cost or purchase price. And all right, there we go. So sales tax is tax rate times purchase price. So the sales tax paid was 38. That's the sales tax rate times the purchase price of 400. Or the sales tax rate, we divide both sides by 400. We get R is 38 over 400. We would like to express this fraction as a percent. Now, one thing I could do is I could go over and do long division. I could do that. That's perfectly fine to do. I might notice something interesting here, though, that 38 divided by 400, well, just hypothetically, if this was 38 divided by 100, I basically have my answer right away. Expressed as a percent, this is just 38%. So can I come up with a way to make the denominator over here 100? I notice that this is 38 over 4 times 100. Or this is like 38 fourths times 1 over 100. So I can kind of split off this 1 over 100 that will make the percent. And then I can just get away with just dividing 38 by 4. Instead of having to do 38 over 400, get a decimal, make it a percent. That's pretty cumbersome. I could do this a little more quickly. 38, I see, has a factor of 2 in it. It's 2 times 19. So it's 19 halves times 1 over 100. And 19 over 2, well, that's like 18 over 2 plus 1 over 2. That's like 9 plus a half. That's 9.5 times 1 over 100. Or this is 9.5%. So 400 being the purchase price, that was what made this problem easier to do, because 400 is 4 times 100. And we could take a little shortcut here and break off that factor of 100 in the denominator and use that to build our percent. And then 19 halves or 38 fourths was easy enough to convert into a decimal. As kind of a side note, if we had done this the other way, if we had said the total cost is 400 and the sales tax was 38, what was the sales tax rate? Well, the total cost is the purchase price plus the sales tax. So I have that the purchase price plus the sales tax is 400, where sales tax means the amount of dollars we paid in sales tax, not the sales tax rate. So my purchase price would be 400 minus 38, or 362. And then what's my sales tax rate? I would have that the sales tax paid 38 equals the sales tax rate times 362. And the rate would be 38 over 362. Okay. So 10% of 362 would be 36.2. This rate would be a bit over 10%. So we'd have gotten a different rate if we had interpreted this problem differently. And this would have been a messier problem to do, which is actually when I copied it over, my thought was that we were going to be doing this problem. And that's why I just wrote, total cost up here. That was kind of what was in my mind, was this two-step problem being a little more difficult than this first example up here. And then I realized, wait, this is going to be a big mess to do. I think the book actually wanted this to be the purchase price. That, the details here did work a lot nicer with this being the purchase price. So I think that was the intent of the book, but when I copied it over, I interpreted it as total cost. And that's a more interesting problem if you have the amount of sales tax you paid and the total cost you paid. That's kind of a two-step problem using both of our formulas from up here in the same problem. Okay, so moving on to commission. So what is commission? The amount of commission is the commission rate times sales. So if you ever, bought a car or, bought a piece of jewelry at a jewelry store or something like that, most of those folks work at least in part on commission. So there's that plus again, looking all, I don't know what I did with that, but okay. Must have changed a font or something somewhere along the way, and it made my plus signs look all funny. But anyway, so definitions, amount of commission is commission rate times sales. So people that, sell cars or sell jewelry, a lot of times get paid commission. So if somebody sells a $10,000 car, they get, something like some proportion of that $10,000 as commission as their pay for selling that car. Often somebody working on commission also gets a base pay. Some people work purely on commission, but a lot of people would get a base pay plus a commission. Note that, we can actually think of tips in a restaurant as kind of like commission, right? The sales would be kind of like the check amount, the amount of food that they sold in a sense. They're not really salespeople. They're not like trying to get you to buy food, but sometimes they actually are, right? Like these bigger chains, like I know Applebee's is really bad for this. The couple of times that my wife and I have gone there, it's almost like buying a used car. They're like, have you thought about trying the, this or that thing? Like they have, whatever, one drink, one appetizer, and one side or something that they always like try to sell you on. Like, and it's always like the same. It was always the same pattern. So I don't know if they still do that. We haven't been to Applebee's in a while. There's just not one near where we're living now. But it's kind of the same thing, right? Is the check that you get at the end multiplied by the tip percentage, typically something like 15% or 18%, maybe 20%, gives the total tip amount. And then their total pay is their whatever hourly pay they got, or whatever amount they want to attribute to that table, however you want to think about it, plus their tips. So this same model can apply to tips as well. We typically call it commission when you don't make sales very often, and we typically call it tips when like you make sales very often, right? Like a server in one, say 6-hour shift might wait on 10 or 15 tables, and so they're like making 10 or 15 sales basically. There we do usually call it a tip, I suppose. I guess the other thing that kind of differentiates a commission from a tip is a commission is usually fixed and it's usually paid by the employer, where a tip is usually paid by the customer and is usually variable. but you can see that these are qualitatively pretty similar. And then the total pay would be some base pay plus a commission, right? So we're not going to really use total pay here, but just, kind of explaining how all of this works. So a lot of sales jobs, are commission based, and, people who are very good at sales can make an awful lot of money. They can make a very good salary because, they don't really care what their base pay is. If they're making a lot of sales, even when it's multiplied by a commission rate that's maybe 2% or 3% or 5%, their commission can be very, very large. On the other hand, if you want to, kind of a slow and steady, like sure thing, maybe a commission-based job, isn't the best for you then. It makes it a little harder to plan financially and so on. Or if you have like a bad month or a bad couple months, it can be really tough. So I don't have the personality where I would want to be in a commission job. I want something a little more, steady, and where you kind of know what your next couple months or 6 months is going to be, but not everybody has that same mentality. Okay, let's look at an example here. So Christopher sold his dinette set for $225 through an online site, and the site charged him 9% of the selling price as a commission. How much was the commission? So the commission is the commission rate, 9%, times the sales, or the amount sold was $225. This 225 is in units of dollars. The 9% is unitless. Commission is going to be in dollars as well. And 9% is 0.09. So we want to multiply those two together. 9 5s are 45. 9 2s are 18, plus 2 is 22. And again, 9 2s are 18, plus 2 is 20. We have 0 decimal places in the 225. We have 2 decimal places in the 9%. 2 here would give us $20.25. Or another example, Michelle rented a booth at a craft fair, which charged her 8% commission on her sales. One day, her total sales were $193. How much was the commission? So commission, again, is the commission rate times the sales. Commission rate of 8% times sales of $193. And I'll write the 8% as 0.08. So doing this multiplication, 8 times 3 is 24. 9 times 8 is 72, plus 2 is 74. 8 times 1 is 8, plus 7 is 15. 0 decimal places, 2 decimal places, 2 in the answer. So the commission she would have paid was $15.44. Any questions on this so far? I don't know why I left so much space in these ones. Okay, next example. Nevaeh is a cruise specialist and earned a $364 commission after booking a cruise that cost $5,200. What is her commission rate? So the amount of commission, the dollars earned, is the rate times the sales. So for instance, if she earned a 10% commission on a sale of $5,200, she would have earned $520. We see the 364 is less than that, so it's going to be a bit under 10%. But for instance, we could think about it the other direction. to get an idea of how big the commission rate is going to be. Should be less than 10%. The amount of commission she earned was $364, and that's the rate, which we're looking for, times the sales, $5,200. So I have number times variable equals number. I divide both sides by the coefficient of the variable R, 5,200. So R equals 364 divided by 5,200. I'd like to simplify this fraction a bit. I might end up having to do long division, but I'd rather do it with simpler numbers if I can. I see that there's a factor of 4 in the numerator and denominator. So 364 is 4 times what? 4 goes in the 36 9 times. So I think 364 is 91 times 4. And 5,200, I'm going to choose to write that as, well, 5,200, I'm going to choose to write as 52 times 100. I would like to eventually express this rate as a percent, and kind of cordoning off this factor of 100 is going to help me with that. So 52 I see as 13 times 4. I might remember, for instance, that there are 52 cards in a deck of cards and 4 suits of 13 cards each. Or I might just, say that 52 is 40 plus 12. So that's 4 times 10 plus 4 times 3. So that's 13 times 4 times 100. My 4's divide out. And now I need to do 91 divided by 13. So let me clean this up. 91 divided by 13 times 1 over 100. This 1 over 100 is what's going to become the percent sign in a minute here. But what is 91 divided by 13? Well, if I come over here, 13 maybe times 5. So this gives me 50, 65. I can go up a little more. 13 times 6. 6 threes are 18. 6 ones are 6 plus 1 is 7. 78. I can go up a little more, and I actually see that 78 plus 13 makes exactly 91. So this is going to be 7 times 1 over 100. Or in other words, it's going to be 7% for her commission. That is a little under 10%. That's what we expected. So that's in line with what we expected. That's a good check. And the answer is 7%. Her commission rate is 7% of this sale. Any questions so far on commission? Okay, then we have a couple of examples on discounts on sale prices. So discount rates and sale prices, and markups and list prices. And then we're going to start into simple interest, 6.4. So we have kind of a motley assortment of different topics today. Okay, so if something goes on sale at a certain percent off, how does that relate to these models up here? So let's think of this model. Let's just bring this down. Maybe I'll do this above the problem, so we don't accidentally use this exact model for this problem. But I know that the sale price is what? It's like the original price minus like the sale amount. Or basically minus a discount is what I'll call it. So the sale price is the original price minus the amount of discount. So if I said, the original price was, or the original price is $100, there's a $10 discount that you can apply. You have a coupon for $10 off. The sale price would be $100 minus $10, $90 is what you'd end up paying. But sale prices are often expressed as percents, right? And that's usually for good reason. If I want to say that, whatever, I have a bunch of clothes, maybe by some certain designer, and I want to put them all on sale, I could go and like tag every one piece of clothes and say exactly how many dollars you get off or how much you should pay for it. But because the different pieces of clothing typically sell for slightly different prices, maybe, this style is a little more expensive than that style. It's just a lot of, calculation to do, right? It's a lot of, you either have to put a new tag on every one of the items, or you have to have some kind of chart where it's like, if it costs this much originally, then it costs this much after the sale. It's much easier to just say 10% off, right? And then you can just make that blanket statement that applies to all of the clothing, and that discount amount goes up or down based on that original price on that basis. So we also have that the discount is the original price times the sales or the sale rate times the like 60% off. Or instead of calling it the sale rate, that's kind of a funny way to phrase it. The more usual way to phrase it is the discount rate. So the word discount seems maybe a little more formal or a little more esoteric than the word sale, but that's usually the way that we phrase things here. So the discount amount is the original price times the discount rate, and the sale price is the original price minus the discount amount. And we can see the correspondence to, say, commission, or even to sales tax up here. Oh, okay. So we can see how things like commission, sales tax, and sale in the sense of a discount off a full price, they all kind of work the same way, right? The underlying mechanics, the underlying like mathematical machinery is pretty much the same. We have a rate that gets multiplied by an original amount, a purchase price, a sale amount, or an original price to make an amount that gets added or subtracted from something else, like base pay plus commission, or for total pay, or total cost purchase price plus sales tax, or the sale price, or kind of the total cost here would be original price minus the discount. So the machinery is almost exactly the same, but the big difference is that a discount is negative. If we really wanted to be pedantic and make these all look exactly the same, I could choose to make discount rate be a negative number, and then I could use a plus here if I really wanted to. But even though these scenarios, these different applications seem very different, computing sales tax on a purchase, finding commission for somebody who's paid based on commission, or finding the sale price of an item in a store, they seem like very different applications. They have effectively exactly the same mathematical machinery working under the hood. I think this is one of the really big benefits of mathematics, is if we understand how to solve one problem, say sales tax, then that gives us a lot of information about how to solve similar problems, say related to commission or tips or sale prices in a store. So this is almost exactly the same scenario. Main difference is we have a subtraction here instead of an addition, but the rest of it works pretty much the same. Okay, so Janelle bought a beach chair on sale at 60% off. The original price was $44.95. Find the sale price. So the sale price is the original price minus the discount, but the discount is the original price times the discount rate. And I see that I'm given the discount rate here along with the original price. So I first have to find my discount. This is like the number of dollars that I save off of what I would have paid if I bought it at full price. My discount is $44.95 times the percent off, the percent that I save, 60%. Or this is 44.95, 60%, that's 0.60 or just 0.6. Remember, when I'm multiplying, I don't need to line up the decimal points. I just kind of push everything over to the right and I count decimal places at the end. 6 times 5 is 30. 9 6 are 54, plus 3 is 57. 6 4s are 24, plus 5 is 29. 6 4s are 24, plus 2, 26. I see I have 2 decimal places in the 44.95, 1 and 0.6, giving me 3 in the answer. So this should be 26.97 as my discount. That's in dollars because the original price is in dollars. So that's not what I pay. That is how much I save off of the original price. What's the amount that I would pay? That's the sale price. That's the original price, 44.95, minus the discount, minus how much I save, 26.97. So I'm doing subtraction here instead of addition. But again, it's pretty similar setup, pretty similar problem solving techniques to these previous couple. I want to do 5 minus 7. I need to borrow. 15 minus 7 gives me 8. I want to do 8 minus 9. I need to borrow. 18 minus 9 gives me 9. Note that when I'm subtracting decimals, I do line up the decimal points. That's quite important here. When I'm multiplying decimals, I push everything to the right, but when I'm adding or subtracting, I line up the decimal points. I want to do 3 minus 6. I need to borrow. 13 minus 6 is 7. 3 minus 2 is 1. So the sale price would be $17.98. Any questions on this one? Okay, another example with sale price and discount rate and so on. Hiroshi bought a lawnmower for the sale price of $240. The original price of the lawnmower is $300. Find the discount rate. So we will start with the sale price equals the original price minus the discount. Now this gives us the discount in terms of dollars. We eventually want to find the discount rate, so that will use the other equation. But for right now, we're just going to find the discount, the amount of dollars that he saved. So the sale price was 240. That's the original price of 300 minus the discount. Or I can kind of solve by observation that discount has to be 60. Or I could subtract 300 over, get negative 60 equals negative discount, and then discount equals 60. So Hiroshi saved $60 off of the original price. But we're asked to find the discount rate, so we need to go a step further. The discount is the original price times the discount rate. And this is what we want to solve for, the discount rate. Right? We want to find the discount rate. We found that the discount was $60. That's the original price of $300 times the discount rate R. Again, I have number times variable equals number. I divide by the coefficient of the variable, divide by 300 to isolate the variable. I see there's a factor of 10 in the numerator and denominator that I can divide out. And I know that 30 is 5 times 6. So my discount rate is 1/5 or 20%. I might recognize that 1/5 is 0.2, which is 20%. Alternatively, I could have done this more with fractions. So I'm leveraging that I know that 1/5 is an easy fraction to convert to a decimal. But I could have also done 60 over 300 is 60 over 3 times 100. 60 over 3 times 1 over 100. Kind of stayed in the fractions world, cordoned off this 1 over 100 as something that will become the percent sign later on, and 60 divided by 3 is 20. So 20, and then the 1 over 100 becomes a percent. So whether I wanted to kind of get a simple fraction and then convert it to a decimal and then a percent, or I would probably just stay in the fractions world because I have such a nice way to make that denominator into something times 100. Either way, we get 20% though, and either way, it's not super difficult, I don't think. Any questions so far? Okay, and then last question in this section. Michael bought a classic car for $8,500. He restored it, then added a 150% markup before advertising it for sale. What is the list price for the car? Now, this one might be a little trickier than we might initially think. Okay, so a discount is like a proportion of some base price that we take off of that we take off to make the sale price. Well, a markup, we have some base price and then we add on to it. So if we're thinking of the perspective of like the business owner, of say the store owner or the store manager, if the store says, okay, I can buy this item for $8 per unit, Now I can't sell it for $8 per unit. I wouldn't make any profit. There would be no reason for me to buy it and sell it in my store. Well, there might be business reasons for that, but at least at first glance, there would be no reason for that. So I say, well, I want to add a markup. So maybe I buy this item for $8 per unit, but I sell it for $10 per unit, and I make $2 for each one of those units I sell. Now that's an incentive for me to provide that market, for me to go through the hassle of ordering it, buying it, having it shipped to me, unpacking it, putting it out on the shelves, right? Some of them might get broken. So that $2 margin there is what gives me that incentive to provide that item. So that's a markup. So if you have the purchase price, so the let's just call it the base price. So similar to up here, we have some base price times a markup rate gives me the markup. Or let me write this further over. So I have some base price times a markup rate gives me the markup. So if I say I want to earn a 10% profit, I want to mark up my items 10%, I would take what I bought that item for as the store owner, add 10% onto it, and then sell it. So the markup rate there would be 10%. That would be of the base price, of the price that the store had to pay for it. And then the actual price, the price, or maybe the list price, what the store is going to list it for or try to sell it for, is going to be the base price plus the markup. So in the example that I said before, if I had a base price of $8 and I was going to list it for $10, my markup, well, the base price to the list price is a $2 difference. And the markup rate, markup equals base price times the markup rate, or $2 equals 8 times the markup rate, or that's 25%. So that item would have a 25% markup. And that represents the margin for the seller. That's what they use to pay their employees, to pay to keep the lights on, to insulate them from losses, right? If some of these products get knocked off the shelf and broken, the store owner has to pay for that. That's items they can't sell, so that's built into this. And they also need to make a profit so that they stay in business. They have a reason to stay in business. Okay, so Michael bought a classic car for $8,500. That was what he paid to get that car. He restored it and added 150% markup before advertising it for sale. What's the list price for the car? We have to be a little bit careful when we're dealing with percentages that are over 100%. It might feel like, well, 150% is like 1.5 times. It might feel like the answer should just be the list price is 1.5 times $8,500. We have to be a little bit careful here, though. So the markup, the amount of money that is going to be added on to the base price, is going to be the base price times the markup rate. This is the markup rate. So he's actually going to add on 150% of 8,500. So the markup is going to be the base price, 8,500, times the markup rate of 150%. Or this is 8,500 times 150% is just 1.5. So 5 times 0 is 0, 5 times 0 is 0, 5 times 5 is 25. 5, oh, wrote that 2 in the wrong place. 2. 5 times 5, 25. There we go. 5 times 8 is 40, plus 2 is 42. We bump over 1 to the next place in our 1.5. 1 times 0 is 0. 1 times 0 is 0. 1 times 5 is 5, and 1 times 8 is 8. We add these together, and then I count decimal places. 1 decimal place in the 1.5, 0 in the 8,500. I should have 1 in my answer. So that's going to be 12,750. Is that about 1.5 of 8,500? Yeah, that seems about right. If it was $127,500, that would be, way off if we forgot to put our decimal point in at the end there, or if we put too many decimal places in and got, $1,275, that's not 1.5 times 8,500. But this seems about right. And then the list price is the base price of 8,500 plus the markup of 12,750. And if we do that, being careful to line up all of our places correctly, we add these together. We get 21,250. And that's in dollars. So he would have paid $8,500 when he sells the car. If he sells it for the list price, he would make a margin of $12,750. That would be something like his profit from the sale. It wouldn't really be profit because he would also need to take into account how much money he spent. He might have had to buy parts for the car or paint or whatever. And but after he took away all the other expenses, what was left over would be profit. And then he could divide that into the hours that he worked and see what wage he made for that investment of time and labor. Any questions on this? But we can see again with markup, right? It's pretty similar to commission or sales tax or discounted sale price. The main difference here being the minus sign, but these are all pretty similar underlying structures, just different kind of surface level details. Any questions on 6.3? Okay, so on to 6.4 then, solving simple interest applications. And let's start with definitions like before. Our main equation here is I equals PRT. I is the amount of interest. Let's take a positive approach and suppose that we are investing money. So this is the amount of interest we receive. Although if we were borrowing money, this might be the amount of interest we owe. The principal might be the amount we invested. R is the interest rate, for instance, maybe an annual interest rate. And T would be the time invested, phrased in the same units as R. So for instance, number of years invested. R could also be maybe a monthly interest rate, where T would be number of months. If we were dealing with something like, say, a credit card, or for something like a corporate bond, they typically are in half years. So R might be the interest rate per half year, and T the number of half years we've invested. And let's look at an example. So find the, oh, and this is what we call Sorry, I don't know if you can hear my dog is barking at somebody in the background. Not sure who's out there, but so this is what we call simple interest. There is another type of interest called compound interest. Um, so simple interest is where you do not get interest on the interest, and compound interest is where you get interest on the interest. So most investments and things like that that you keep invested for a long period of time, they end up getting compound interest rather than simple interest. But here we're just dealing with simple interest. Compound interest, the math is a little more complicated. Okay, so let's find the simple interest earned after 4 years on $900 at an interest rate of 6%. And we really should say per year. Or sometimes we would just say an annual interest rate of 6%, something like that. Another way to say it. Okay, so I is the amount of interest. That's what we're looking for. 4 years is the time period in years that does match the rate of 6% per year. If this was phrased in a rate of, percent per month or something like that, we could figure out how many months are in 4 years, 4 times 12 or 48 months, So if we needed to, we could convert one to the other. And the initial amount, the principal, is $900. So I equals P times R times T, or 900, that's in dollars, times the rate of 6%, times the time of 4 years. This is basically 6% per year times 4 years. So my units of years cancel out. I have one in the numerator, one in the denominator. They basically divide out. My amount of interest is in units of dollars. That dollars from the 900 is left over. That's the unit that I get for amount of interest, and that makes sense. That's a dollar amount. Okay, so 6%, I could write that as 0.06, but I see that if I write it as 6 over 100, I think that's going to work a little nicer here. So I have 900 times 6 over 100 times 4, and this is the calculation I want to carry out. I have three things multiplied together. I can really think of 900 and 4 as like 900 over 1 and 4 over 1. I really have three fractions multiplied together. I multiply all the numerators. And then I multiply all the denominators, the over 1 times 100, and then the other over 1, so just a 100 down here. And in fact, I see that 900 is 9 times 100, so I can just divide this out and make a 9. 9 times 6 is 54, so I need to multiply 54 times 4. Or I really see that this is 50 plus 4 times 4, 50 times 4. 4 times 50 is 200, and 4 times 4 is 16, and that's in dollars. So over this 4 years, on the principal of $900 invested at 6% per year, I would have made $216 of interest. So not too bad for just sticking money in an account and letting it sit there and letting it work for you. Let's look at another example. Find the principal invested if $177 of interest was earned in 2 years at an annual interest rate of 3%. There we go. So I see my rate is 3%. and that's per year. My time, 2 years. My amount of interest is $177. And I want to find the principal. So what do I have? My equation is still I equals P times R times T, but now I'm looking for P, and I have I, R, and T. Or in other words, I know that 177 equals P times R, 3%, times T of 2 years. This is like 3% per year times 2 years. So the years go away, they divide out. P, the principal, will be in dollars because 177 is in dollars. So what can I do then? I see that I have P times 3% times 2. I guess I could just really rewrite that as 2 times 3% is 6%. So getting 3% per year for 2 years is the same as just getting a total increase of 6%. And now I have number times variable equals number. I just divide by 6% on both sides. So I have P equals 177 over 6%, or that's over 0.06. I can bump my decimal point 2 places to the right in the 0.06, and the same in the 177. So that's a 177 with 2 zeros after it, divided by 6. Does 6 go into 1? No. Does 6 go into 17? Yes. 6 goes into 17 twice. 2 times 6 is 12. 5 left over. Bring the 7 down. 6 times 10 would be 60. We don't quite make 10 of them, but we should get 9. 9 sixes are 54. 3 left over. Bring down the 0. 6 goes into 35 times. 5 times 6 is 30. 0. Bring down a 0. 6 goes into 0. 0 times. 0 times 6 is 0. We have a remainder of 0. Nothing left to bring down. So my principal was $2,950. Does this seem about right? Well, 2 years at a rate of 3% gives me 6% interest. So more interest than that would be, say, 10%. What is 10% of 2,950? That would be $295. That's a bit more than $177. Kind of seems like it's in the right ballpark, right? I'm not off by like 10 times as much or 10 times too small or something like that. So a principal of 2,950, yeah, that seems pretty reasonable. And then let's find the annual interest rate if a principal of $2,600 earned $468 in 6 years. So maybe we buy, a baseball card or something like that for $2,600, and 6 years later, it's worth $468 more when I sell it. What was my annual interest rate? What was my annual rate of return? So I'm looking for R. I have my principal, $2,600, my interest, $468, and my time, 6 years. So I have 468 equals 2,600 times R, my rate, times 6, my time. Or I see I really just have 6 times 2,600 times R, that's number times R equals 468 equals a number. I just divide both sides by the coefficient of R, which is 6 times 2,600. I see a couple of things here. Number one, I have some cancellation that can happen, some dividing out of common factors. But number two, this 2,600, that's a nice multiple of 100. I want to express my R as a percent probably, so let me just make this 468 over 6 times 26, and I'll break off this 1 over 100. So I'm breaking 2,600 into 26 times 100. Okay, so I see that I have a factor of 2 in the top and bottom. Probably even have a factor of 4, but let's do 2 first. So 468 would be 234 times 2 over 2 times 3 for the 6 times 2 times 13 for the 26 and times 1 over 100. So let's divide out a 2. 234 would be, well, 230 would be 115 times 2. So 234 would be 117 times 2 over 2 times 3 times 13. And that's times 1 over 100. So I can divide out the 2. 117, that doesn't seem like a super nice number, but I do note that 7 plus 1 plus 1, if I add the digits up, that gives me 9. That's a number that's divisible by 3. So 117 is divisible by 3. Let's figure out what it is. 3 goes into 11 3 times. 3 goes into 27 9 times. So it seems like 117 is 3 times 39. And actually, I noticed that 3 times 13 is exactly 39. So these will divide out. So 3 times 1 over 100 makes 3%. I've kind of kept this 1 over 100 separated out so that it can become the percent at the end. Everything else simplifies down to just the number 3. I earned a 3% rate of interest over 6 years on this investment. So not going to blow anybody away, but it's maybe keeping up with inflation, right? So maybe this was a safe investment and I'm happy with a 3% rate of interest, or maybe I was hoping for more than that, right? I could have put my money in the stock market and done better than that. So maybe this was a rate of return that I'm not super happy with on this investment. Any questions on anything we talked about today? All right, when we come back, let me stop the recording.